When it comes to understanding how the brain functions, scientists have done a great deal of work on studying macaque monkeys. They're our evolutionary relative, and we share 93% of our DNA with them. And in a lot of ways, our brains are very similar. Even for high level operations, such as learning, memory, and decision making, our brains work in comparable ways. However, when it comes to sound, scientists have now discovered that humans seem to have a unique edge in how we perceive pitch. I'm Ankita Nirban, and I spoke to Bevel Conway, an investigator from the National Institute of Health in Maryland, on his recent work comparing how humans and monkeys respond to sound. First, I started by asking him, what are these monkeys like?
Macaque monkeys are about the size of a medium-sized dog, and the rhesus macaque monkeys have a long tail, and they look like Curious George.
And why exactly have you chosen these specific monkeys to do your experiments on?
Macaque monkeys are the standard model that have enough similarities with the human that we can make the leap of faith that what we learn in them can tell us about the human condition.
In this study, you were comparing how the macaque monkeys and how humans respond to auditory stimuli. And what did you expect from the study and what did you find?
In this study, we compared the brain responses of monkeys and humans to different kinds of sounds. And we were particularly interested in measuring the responses to the properties of sounds that we call pitch. And so, given the gross anatomical similarity between macaque monkeys and humans, and given really the functional similarity at the level that it has been asked, one idea is that, well, we'll see basically the same thing between macaques and humans. On the other hand, you might say, well, macaque monkeys don't have music and language, and since pitch is an important component of music and language, maybe macaque monkeys and humans would be very different in their brain responses to sounds with pitch. So we really didn't know.
What did you find?
Monkey brains don't respond as well to sounds that have pitch, and human brains respond very well to sounds that have pitch.
Does this mean that the sounds that we hear when we experience life are very different to what the monkey is hearing or perceiving if they experience the same things as us?
Yeah, I think that's a very nice way of summarizing what the results might mean. So, in our work, we've shown that macaque monkeys and humans have very similar organization in the visual cortex. So, they have similar responses to color and motion and faces and so on. And so, when I look out in the world, I can rely on my own intuition, rely on my own subjective experience to infer what the monkey might be seeing and experiencing. But our results in the auditory domain, this recent paper, suggests that the monkey's experience of the auditory world is perhaps very different from our own. So that when we listen to a piece of music and hear those rousing chords and sonorous melodies and so on, maybe the monkey isn't hearing those so much. What he's hearing or it's hearing is just the kind of noise component that's underlying or is in the sound as well, but that for us is sort of eclipsed by the rich pitch components.
Why would you say that pitch is important to humans?
It's very clear that pitch and pitch elements are essential pieces of language across all cultures and in music. And so anyone who has a favorite song will know how important that pitch is for your emotional reaction to the world or to extract meaning from what you're listening to. And so it may point to something very special about what pitch does for us and about the kinds of meanings we're looking for, our brains are evolved to pick up in the world. And they're particularly relevant. The sort of general category of information that pitch gives us is about social communication. It's about us relating to each other. Pitch tells us a lot about how we talk to each other, how we communicate with each other, how we get information from other people in our society.
That was Bevel Conway from the National Institute of Health, whose work has been published in Nature Neuroscience this week.